Parker Hannifin are a $14 billion corporation, and they make valves in all different shapes and sizes from irregular shaped castings. So Gio and Joe today are going to show us how they're machined.
So Lloyd, can you tell us more about the Sheffield facility?
So in Parker Hannifin, Sheffield, we manufacture a range of valve-based products. And what we do, we have various raw materials, whether it's billet, casting, and we machine most of that product, and we offer a very wide selection of valve-based products to our customers. One of our major USPs is offering a lot of customization to our customers, and we also share our engineering prowess. But some of the challenges that come along with that is obviously different threads and tooling and machining features, but also some of the design complexity we've got to overcome. So what we see big challenges in is the workholding of some of the products, because typically the people who are designing for the function tend to not speak to the manufacturing engineers. So we have some very weird and wonderful designs, and especially on the casting front, when we get casting variability, we have to spend a lot of time looking specifically about how we grip and hold it to get into our machining centres and to accommodate for some of that variability. But the way we do this successfully, we also look at some of the form tooling, because we have some very weird and wonderful forms that we need to achieve on the internals of some of these valves. We actually manufacture some of our own form tooling in-house, so that gives us maximum flexibility on being able to do that process.
Now, there are many variants of valve bodies that you manufacture at Parker in Sheffield. Do you manufacture the jigs for each individual valve body?
Yeah. We've had a tool room since time began, really. Obviously, you'll see a lot of tools in a bit when we go and look at them, what we do. So yeah, and that's where we make sure our apprenticeships start off, so they learn as well. So the future for our apprenticeships is in the tool room, making jigs and fixtures and learning the proper, because to me, if you don't know how to hold and make something to hold something to manufacture, then when you get a problem on machine, you're a bit lost. So the grounding is there, yeah.
Absolutely. And just to clarify, Craig, the volumes that you manufacture them in are very low as well. So how important is setup time and the speed of setup?
Oh yeah, it's paramount to us. You know, we are small batch, fast turnover. We might be doing 6 of these, we might be doing 100. Yeah, we've got 5s, 4s. So I keep turning, but when you look at that jig behind me, like I say, it holds 4 at a time. Also, we can manufacture 4, 8, and we can not produce stock. So if a customer asks us for 8, we can immediately do 8 straight away. It's preset tooling, so that's the main thing. So the setups went from 4 hours, the old way we used to do it, down to 20 minutes. Wow. Which is massive.
Wow. So you mentioned tooling, that's our next stop. Let's go and have a look at some of the tooling that you use to manufacture the valve bodies.
Yeah. Parker Hannifin, looking to reshore components from other areas of the world. How do the cutting tools help this?
Oh, massively. Obviously we're a short batch, like we've said, so we need quick turnovers. So our main sort of win on every component that we use is the preset tooling. Yeah. So as you can see here, we've got array tooling that's all set, ready to go in the machines. So instead of spending an hour, 2 hours setting tools up, it's 5 minutes, 10 minutes. So the quick turnaround, and also when we buy offshore, we have to stock, because obviously the lead times and everything. When we manufacture in-house, you can make 2, 3, 5 quick turnover, quick round straight into stock.
Mm-hmm. And looking at some of these tools, you've got form tools, you're reducing operation, some of these 3 or 4 different diameters, so that's something other manufacturers may not be doing, making you more efficient here.
Yeah, that's right, yeah. What we call multi-tooth cutters, so on the brass and gunmetal jobs especially, you can have 5, 6, 7 diameters with little chamfers and everything, so it's just one plunge in, one plunge out. You're saving tool changes, backwards and forwards. It's job done in and out, yeah.
Gio, Parker Hannifin, lots of their components, they will start as a regular, so how are we going to hold them?
irregular castings can be an absolute nightmare because of the casting variance. Now, when you've got examples such as this where they're really irregular, Parker actually make their own bespoke fixtures to hold them. Now, if you bring the camera in a little bit closer, you'll see there's lots of adjustment areas built in within the fixture to allow for the casting variance. We've got one here. We've also got one at the bottom. I don't know if you can get the camera underneath that. This particular lever here pushes the moving jaw effectively onto the fixed stop. We're hitting the casting from one side to produce the bore, but we've also created the back end of the fixture, clearance holes to hit the back end of the bore and the top flange.
So another question, Gio, these start as billets, these start as castings, but there's no datum as such, is there? Because we've got a fixed jaw, so how do we get over this?
So if there is a casting variance, it can be an absolute nightmare if you're setting the datum off the fixed jaw. And the only way to get around this really is by probing it in the machine if there's a big casting variance, or if the castings are good castings and the casting variance is small, the casting still may be in tolerance even though there is a slight variance. But without a shadow of a doubt, castings are probably one of the hardest components that you'll look to machine, Joe. But not only, castings, holding them is essential, but also cutting them, Joe. The cutting of the castings, how are they doing it at Parker?
Well, at Parker's, they're big on reshore, and they like to bring as much work in-house as they can, which is great for the Sheffield area and great for the people within this building. But you're absolutely right. To remain competitive, we've got to get these operations down as far as we can. If we look at the component around the back here, there's actually 5 different diameters within there. 1, 2, 3, 4, and there's another one at the back. And this tool here, as you'd probably guess, there's five diameters to it. 4 diameters and the chamfer on the top. And essentially, we're doing it in one, Geo, So maybe you'd have done it with a boring head, a couple of different boring heads, or maybe you'd have done it with some end mills. You're not going to win work like that, Gio. You need to do it in one to remain competitive. And that's what they do here. Incidentally, these are designed and some of them even manufactured here in this building.
Now, I believe the carousel on this particular machine holds 180 tools. Now, they're all preset as well, Joe.
It's key again. The days of Parker Hannifin doing 1,000 in one go, they're gone. They're doing a low volume, high mix of components. Therefore, you can't be setting jobs, again, to remain competitive. So having the tool carousel is key to this, and having the tools preset, only seconds that. So today's Cycle Time Challenge, I'm here with Harry on the Star 32J, and it's a stunning component. Harry, what is the component to start?
Yeah, this is a stem, and it sits centrally in the middle of the valve body, and it operates up and down as what's actuators on how it closes. So at Parker here, castings are not the only thing that we specialise in. We also do stems, like I say, along this part on this Star machine, which is gripped by 3 collets. So obviously it has to do the part in various different stages, and that's what can be very tricky when it comes to machining this complex part.
Yeah, so what's the thread, and more importantly, what material are we looking at?
Yeah, this is nitronic material, and the threads are stub acme.
Okay, so there's a lot of work into this component. So get your guesses on the social media of your choosing, put them below, and the winner will get a goodie bag.
Once we've done the primary process and the materials, we've got to assemble these together. So we'll do, let's say, valve bodies, we'll do long stem extensions, and then we've got to do various types of testing on this product. So every single valve that leaves this factory must be pressure tested. So once we've assembled it, we submerge it in water, and typically somewhere in the region of 50 to 75 bar, and we fill it full of gas, and then obviously we're checking that the valve is sealed and it's a good pressure retaining vessel. But we also offer a product line called Bestabel Marine, where that's for high-end liquid natural gas ships. and that needs full third-party approval as well. So they 100% witness our cryogenic tests, where what we have to do is we do a test at ambient temperatures, this temperature now, does it seal, but then we submerge it in liquid nitrogen at 200 degrees below C, and we have to perform the same test to show that the engineering of the valve works in both temperatures.
So all that's done here in Sheffield. So for the people that don't know of Parker Hannifin, just give us scale of the group.
So Parker Hannifin is north of $14 billion global business. It's a huge conglomerate. We're in every region of the globe. Within the UK, we're part of an instrumentation products division Europe, which is a 3-site division. And then in Sheffield, we've got the Bestabel, Conflow, Hurl, and Brett Bigamatech product lines on offer.
So, and we're here today. What's it going to look like in 2, 3, 5 years' time? Is there more investment around the corner? You're looking to grow the UK operations?
Very much so. So we've very recently made an investment of about $500,000. So we've put an automated CNC lathe cell in, where we've got DMG Morrit NLX 2000. We've got an ABB flex loader robot. So we're really planning for the industry 4.0, where a lot of things are becoming more automated, and being able to do these without as much human intervention is allowing us to do them competitively, and it's more of that type of business. We've looked at automated robots, automated clean lines, so we can get most of our key skilled operators doing value add activity on a regular basis.
All those parts have been machined and assembled, but now they need to be tested, hence why we're here. This is an area, a cryogenic testing area, where they will dip the valve into liquid nitrogen that sits at minus 196 degrees, testing that valve to work in extreme, very cold temperatures. There are so many other testing areas here, but we don't have time for that today. So thank you for watching this week's Swarf and Chips. Don't forget to like, comment and subscribe. Get your notifications by clicking on the bell. What do we always say, gents? Keep those spindles turning.